session on the FHIR DevDays. My name is Marco Visser from FHIR, and I will be your moderator of this session today. If you have any questions during the session, please type in your question in the Q&A tab on Whova, and I'll make sure that those questions will reach the speaker. Or in the end, you can open your mic yourself in Zoom, and then you can ask your questions yourself. This session speaker is Ardon, and he will give you a Let's Build session about profiling with Forge. So are you ready, Ardon?
Yes, nice.
You can take the screen, and you already did.
Thanks, Marco. Nice. So welcome. So you arrived at a Let's Build session where we will go through profiling with Forge. But first, let me briefly introduce myself. I'm Ardon Toonstra. I work at FHIR. And FHIR, besides organizing DevDays, is involved in well, all kinds of activities around FHIR. We build products, we offer services and provide training. For myself, I'm a FHIR consultant at FHIR, where I'm mostly specialized in creating FHIR profiles. One of my biggest projects is creating the Dutch core profiles, which are being used in, for example, the MedMij program, which is a program set out to enable all the patients in the Netherlands to get access to their data. So that's for me. Today's goals for this Let's Build session is to learn how to start profiling using Forge. It's really an introductional session on how to get yourself set up with Forge and create your own profiles. And we're going to do this by going through the exercises, which contain requirements that we will create in profiles. You can find those exercises in the bit.ly link shown on the slide. And this link is also provided in the Whova agenda. And in this Let's Build session, I will demonstrate, or I will actually create those exercise, or I will do the exercises myself and show you how to do it. And the exercises will remain available after DevDays, together with the answers in it too. But before we go into depth, I would like to have a quick rehearsal of why we're actually going to profile. Before this session, Miriam Baltus, a colleague of us, gave an introductional tutorial about profiling. So she covered quite a lot on this, but to get everyone up to speed, just a couple of words on this, because FHIR is an international standard, and if you want to implement it, you will likely not get away with the FHIR specification right out of the box. You likely need to provide documentation on your implementers on which elements they need to implement, and for example, which terminology is required to exchange the information. And so FHIR made a whole mechanism, a method on allowing to adapt the FHIR specification itself to local use. And well, that's what we call profiling. And that mechanism has a couple of key features, which is that you define your requirements in a structured manner using, for example, the structure definition resource, which is independent of the serialization format. So it can either be JSON or XML or Turtle. That shouldn't matter. And those profiles or the structure definitions, they almost act like code themselves. So they can be quite well managed and versioned in a code repository. So besides having the function as documenting the requirements to your readers or implementers, they are also very handy in allowing validators to actually test and validate of instances if they conform to the requirements you made. So I think those are definitely two main purposes of why you want to create profiles. One is to document your requirements to your holder, and the other one is to actually allow validation of resources that are being sent, for example, to a server. Well, if you start out creating profiles, one of the things you will definitely need to do is to give your profile a unique identifier, which every profile will get. And this is also called the canonical URL. And on the slide, you see some examples on, for example, how the FHIR specification provides the canonical URLs for their resources, but also for real life examples from profiles in the wild, which acts as a unique identifier for the profile. Okay, so far for the theory. In a minute, we will open up Forge, which is a graphical editor to create those FHIR profiles. Those are, generally speaking, structure definitions where you can make profiles on resources or on extensions. But besides that, Forge allows you also to create logical models, search parameters, and operation definitions. Forge itself is designed for a Windows desktop, as a Windows desktop application. It's not very suited for Mac or Linux, but there are ways to run it on those platforms too. For example, if you have a virtual machine, or you can try Wine to run it. For this presentation now, I expect that you already have Forge running, because we don't have any time to go into that. And lastly, Forge is free for non-commercial use, or if you want to use it for personal or educational use, like we're going to use it now. But if you're about to make profiles for commercial use, we license it together with the paid plans of FHIR, which is another tool of FHIR. Because Forge is not on its own, FHIR provides a whole ecosystem of tools that interact and integrate with each other. So Forge is there to help profile auditors to create profiles, and you can publish them on simplifyr.net, which is a global FHIR registry for FHIR profiles. So you can publish resource or profiles there, but Simplifyr is also made as a collaboration platform where you can work together as a team with your team in the same project, creating profiles. And it has all kinds of features that help you provide the best profiles possible. For example, it has a quality control feature helping you validate and so forth. And on the right side, FHIR also offers a FHIR server named FHIR server, which can import all those structure definition, all those profiles in the validator, for example. And lastly, FHIR also works on the .NET API for FHIR, named FHIR SDK. Okay, so far the intro. Let's open up Forge and our exercises first. 1 second. So if you move to the bit.ly link that you can find in the Whova agenda, you will end up here in this example implementation guide, where we have 8 steps in total, which we will cover now, one by one. And I don't think we will make it to the end in this time. Perhaps we do. And if you have questions along the way, please hit them in the Q&A or open up your mic and ask the question. First off, we will start with the basic profiling concepts. I will zoom. If my screen is too small, please let me know. So have a look. As the first exercise, we are about to start creating a profile and do some basic profile. Every step has a small use case that says something about the requirements made by a fictive organization that we will need to capture in profiles. So here we have a hospital that wants to receive patient data from general practitioners. they decided to use FHIR, and they want to start out with the administrative data of patients, and they've got some requirements. So first one is a patient has at least one name, and each name has at least one family and one given name. Date of birth and gender are mandatory. Photos should not be allowed to be added. And lastly, the hospital can only capture if a patient is deceased or not the actual date time. So the first three are cardinality constraints. And the last one is an element type constraint. Okay, so let's open up Forge. Let me have a look where Forge is. One sec. So here's Forge. If you have installed it through a Simplifier, you should already have a Simplifier account. And once you run Forge, you will need to log in to your own Simplifier account. I've already logged in, as you can see here on the top. And the first thing we need to do is to create a profiling folder and select it. So for now, we can go and select this, just a folder on your PC. And say select folder. So this is our working directory for our assignments now. And then, we're going to make a profile. So we select new, say new profile. And then we need to find the best resource suitable for the requirements made. Well, in this case, that's pretty easy because we're about to do something with patient data. So we're going to find the patient resource, select it, and open it up in Forge. So here we have the FHIR core patient resource loaded into Forge in the element tree. And Forge is showing here all the elements of that base resource. But before we get profiling, we first will assign some important metadata to it. So we move to the properties tab, and this is the place where we are going to give our profile that unique identifier. We're going to give it a canonical URL. So as an example, you can put your own name in it with the country code and say something like, okay, this is patient X. Well, we can also give our profile the same name. And here you've got all other kinds of metadata describing the profile you are making. But for now, this will be enough. We have a unique name. We go back to the element tree, and let's have a look at the assignments. What we need to do. We need to make sure that our patient that's being sent to us at least has one name, and it has one family name and given name. So we will find the appropriate element for it, which is patient and name. And I can see that the base cardinality of that name is 0 to star, which means you can send, this name can repeat indefinitely. But we want to make sure that if something is sent to us, it needs to have a name. So let's make it 1 to star. So now the instance of this patient has at least one name. And within name, a family should be made mandatory, and the given, it should have at least one given, if I'm correct. Yeah, so that's the first requirement. Then the date of birth and gender, both two very straightforward mappings. So let's make it mandatory, birth date as well. A photo should not be allowed. So instead of making it mandatory, now we're going to say here, patient photo that should not be in the message or in the instance. So let's set the cardinality to 0. You can see Forge stripes it away. So far, the cardinality constraints. And then the last one was the type constraint. So in this case, the hospital only wants to know if someone is deceased and not if someone, not the date time when someone is deceased. So here we see the deceased element, which is a polymorphic element seen by the X in boxes behind it. And on the right side, we can see that it has two types. It can either be a Boolean or a datetime. And we want it to be only a Boolean. So we will uncheck the datetime. And so far, we have now been through step 1. And we can, well, let's save this patient for now. Say patient X. Then we can move to step 2. If there are no questions. And if you want to check, if you want to do this afterwards for yourself, the results are under every step. You can click it open. And here you can see the profile that's being published on Simplifier with the differential view. So this also shows the profile. And if you click on it, you can download it and import it to Forge and see and compare if you made the same constraints. So step 2, let's go to the extensions. So the Hospital X wants to capture additional data on the patients, which is not represented in the base resource, and the following requirements are specified. So they want to have the place of birth and optional information on inclusion into one or more clinical studies. So in this case, let's have a look at the place of birth. For if you're about to search or you need additional elements that are not in the base resource, as a first starter, you should have a look if the FHIR Spec itself already defined a core extension for it. In this case, that's that's the case. So let's move to the FHIR specification and go to the patient resource. I'll zoom in a bit. So this is the page in the spec that describes the patient resource. And on the top, you've got some tabs with additional informations. And you also got this tab that about profiles and extensions. And if I open it up, here you see a list of extensions defined by HL7, which probably didn't came through the 80% rule, but were deemed important enough to at least make it into a core extension. So we're going to reuse this extension, the birthplace. Oh, we click on it. There are multiple ways to get this in Forge, but I will just demonstrate this way. We now go to the raw XML or JSON variant, and let's download it. Say save as, and we will save it to our profiling folder. And then navigate back to Forge, and here we say we go to the elements that we want to extend. So we move to our page, to the root of the patient, and we say extend. We first need to refresh the folder. So now it's listed here as well. And if we now click on extend, Forge shows you all the extensions that are capable of putting here. Let's go for the birthplace. Give that extension a nice extension slice name. Birthplace seems logical. Oh, it's mandatory. Conform to. And now we have extended our patient resource with the patient birthplace extension, which holds a value where, which is an address, type address, and in the instance, an additional address can be sent that represents the birthplace. Let's move back to our assignment. So this was adding or reusing an extension, a simple extension. And the second requirement is to create a complex extension ourselves and include it. And in this case, this is really not a real world example, because we're going to perhaps recreate something that has its own resource in FHIR. But this is just to show you how to create a complex extension in Forge. So we navigate back to our profiling folder, click new, and this time we say not a profile, but we're going to make an extension. Let's say, okay. first, again, let's give it a URL. Let's call this Ext inclusion. So give it a name too. And what we also see is that Forge already has some inline validation, and it now says that the profile we've created is not yet valid, because, well, if we click on it, it will direct us to, or it doesn't, it should direct you to the place where the problem is. But if you create an extension yourself, you need to provide information on where that extension is allowed to be used. So in this case, you need to provide a context. And here, using the expression button, Forge helps you to select where this extension is allowed to be used. And well, that's in the patient resource on the root, would be a more appropriate location. So we select the patient, and then here you can select an element where the extension is allowed. Well, we put it on the root. And this is fixed, so the complaint is gone. And now we can get to actually creating the extension. So now we have a simple extension where you can choose which data type it should be. And instead of profiling this, we will add, well, 3 sub extensions. And we can give it the names that are given in the assignment. So what do we say? We want to have a clinical trial number, a period of involvement, and a status. So let's say clinical trial number should be cardinality 1.1, and then we can select here the type. This should be an identifier. Then the second one can be a period. Also, let's set the right type. Come on, period. Where are you? Here, there you are. And the last one, a status. So, inclusion status. And we can make it, well, a code or a codable concept. For now, just make it, let's make it a codable concept. And then we're ready. Normally you would provide additional metadata on when that describes the extension and so forth. For now, for this trial, we will just be happy with it. So we can save it. And we will want to make this extension shown in the patient profile. So again, let's refresh it, extend it. And here we can see our just created extension, which is now added. Just give it another slice name. Inclusion status, et voila. Or an optional, let's make it this. So far so good. So now we've added a simple extension and a custom-made complex extension. Let's move on if there are no questions. Step 3 is about profile references. So Hospital X wants to capture data on the conditions the patient have and want to model this in FHIR. And they make the following requirements. So the condition resource should have a link back to the patient model we previously made. They want to know the general practitioner that recorded the condition, and that general practitioner needs to have at least one identifier and one name. Okay, so we will need to create 2 additional profiles. Well, for the conditions, it's also very straightforward, the condition. So let's select here the condition resource. We can also already add the metadata over here if we want to. So here we can change the canonical URL and say condition X. Saves us a little bit of time. Okay. And now we have here the condition-based resource, which we will need to give a link back to the patient profile. And that's done through the subject element. So a condition can have a subject, which can be, as you see here by the reference, either a patient or a group. And we want to make sure that that subject, that patient, should also conform to our data model. So what we're about to do is we're going to select the URL or the canonical URL we've given to that patient resource and put that into the condition profile by clicking on target profile and copying in that canonical URL. And we will remove the base canonicals. So now we profile that this reference should definitely be conformant to the previous profile we made. And the other one is about the general practitioner as a recorder of the condition. Well, general practitioner is best represented in a practitioner resource. So let's make a quick profile on practitioner. So again, practitioner X. I can say again. Oh, perfect. It also has some quick requirements. So it needs to have an identifier and one name. Let's make it a little bit easier to see. So we make the identifier mandatory, and let's have the name too. And again, let's copy the canonical URL, go to the condition resource and find the appropriate element, which is the recorder in this case, which can be a lot of different resources according to the spec. But in our case, we only want to provide a practitioner resource as a reference for this recorder. Well, let's make it mandatory and save this one too. So this is step 3, where we've shown how you can profile references. You can do other things here too, but this is the simple version. Let's move to step 4, terminology bindings. So Hospital X can only handle certain terminology codes and wants to capture specific data on the conditions that the patient has. So they have the following requirements. The conditions need to have coded information that is the identification of the condition. And they want to register those conditions codes with SNOMED. And they even only can handle the clinical finding codes from this SNOMED code system. So we want to profile the value set binding on an element. But we are not going into detail on how you can create value sets. We will just find one and reuse it. Let's move to the shortcut where we provided a link to the value set that we want to reuse. So here we have a value set defined by the FHIR core spec. It's in the core package, SNOMED CT finding, and it says something like include all codes from SNOMED where concept is below or after this code. And what we're going to do is quite similar to the profiling reference step before. we're going to select the URL of this value set, which is over here or on the top, canonical. Going to copy it and then move to our condition profile and find the right element for it, which is code. If we see the code element, this is the identification of the condition. Well, we want to have it mandatory because the condition needs to be exchange coded using a code. And we're going to adjust the value set binding to it. So open up the value set binding. And here we can see that in the base spec, there's already a value set bound to it. But it has a binding strength of example, which is the lowest binding strength. Here, the International FHIR Spec here says something like, okay, this, you can think of these codes, but we actually have not standardized it quite enough. While preferred says something, okay, we have thought about it, and this is kind of the direction you want to, you should use. Extensible is a bit heavier already. That's something in the meaning of you should use these codes. But if your code is not on it, you can give a code from the same code system. And if that's not possible, then you are allowed to add your own code. But you should definitely try to do something with the codes on that binding set. And if it is required, you need to provide at least one code from that value set. In our case, we want to put it to required, and we're going to adjust the value set reference over here. So, and a small change. And now we say that these codes should conform or should be one of the codes defined in this value set. I think that's it for this step. Yeah, so this is step 4. Now we are doing on time. Still got 15 minutes. So let's move to step 5, derived profiling. I think Miriam covered this in her tutorial as well. So profiles can be layered on top of each other. Every next profile, derived profile, inherits all the constraints in the base profile, but they can also add other constraints, which we will do now. So for example, Hospital X is in the US and they want to be compatible with the US core profiles, and they want to create a profile on the US core immunization profile and add some requirements to it. So for this, the easiest way would be to go to Forge, move back to the profiling folder. And then here on the top, you have another tab called dependencies. And here we can search for any published package and instantly retrieve it and install it on our computer. And then we've got all those profiles and conformance resources to our available, or they will become available to us. So if you go to Simplifier, and then you can search, for example, well, let's search for US. And now we see all the FHIR packages that are being published on Simplifier. Let's move to the US core one. Here, US core. You can select the package version. We will take the latest and click the add button. So what Forge did is it instantly installed this package and all its dependencies of this package. So as we move back to the project folder, it will need to have some time in loading all those resources. So let's give it a couple of seconds. Well, here we've got a very big list of all the stuff that is in those packages, but the folder view gives it a bit nicer. So here we can see that we have got the US core package, and it also downloaded its dependencies, which is the R4, FHIR Spec, and some other package. Not sure what this is. If we go and navigate into this US core one, and go to the package, we will see all the conformance resources that US Core has published. But let's find that immunization profile, which we have over here. And then you can just right click and say new derived profile. And well, say we will just call this immunization X. And again, provide our own canonical to it and say, okay. Forge is now creating a derived profile, and it inherits all the constraints being laid out in the US Core profile. And you can see that, for example, on all the must support flags that are being set by the US Core profile. So to finish it off, we need to put some simple profiling constraints in this thing as well. So the path by which a vaccine product is taken into the body needs to be known, and the quantity. So those are two things that need to be made mandatory on the root and the quantity. And well, now we've created our derived profile, which is compatible with the US Core one, because I can't make constraints that are wider than the base profile. So the last profiling step is slicing, which is always, that can become very, very complex. But you will need to do slicing if you want to profile requirements or different requirements to the same repeating element in FHIR. Or if you only have one requirement, but you want to leave open the other possibilities. So let me show you in the profile how to, for example, slice things. So here in this example, the general partitional data needs to have exactly one active United States national provider identifier, and allows other identifiers too, but if they are, but only if they are marked as old. So let's go to our practitioner profile. And we are here on the identifier slice, which is by default already a repeating element. And we have two different requirements for this element. So we would want to make two slices, one for the active identifier and the other for the old. So we can leave it mandatory. You need to be on the element, slice it, and then add two slices. So let's say active, I'm not sure what the name was. Well, NPE. And the other slice will be the old NPE. And they will be differentiated by their use. So the identifier use says something about if it is active or not. So the active one will get a fixed value that says, okay, this identifier piece is the official one, while the other is the old. We can make this, it needs to have one, at least this active one, and it can have older ones. And well, we need to know a system for the identifier. And if we navigate to the identifier systems, we can find the MVE, the one for the United States. It has a URI for the system and an OID. Let's use this one. And we can already give this as a fixed value over here. Okay, and Forge is still complaining that the slice definition is not valid, so we will solve that. Because if you create a slice, you will need to tell the profile, or you need to tell the validator how it can differentiate those two slices. How does it know in the instance to which slice it belongs and to which slice it needs to be validated again? So to do that, you need to go to the element you sliced, and there you will have the slicing details where you can set up a discriminator. So here we have set two different differentiating fields in the use, for example. One is active, the other is old. So our discriminator will be the value that is inside use. So now the validator knows if in the instance something is being sent, it knows based on this use value to which slice it should validate. Okay, I'm going to run out of time, so I will have a quick look on the next steps. So I will just not demonstrate this anymore, but you can try this out yourself. If you've created all your profiles, a nice new way is to publish them all to Simplifier, and you can do this by zipping your entire folder and upload it to zip. Or maybe it's nice to show if you want to use the integration of Forge and Simplifier, you can, for example, hit Ctrl-U or navigate to the file and say publish to simplifier.net, where you can select your project. You need to first create a project, of course, and you select your project and say save. And then if you look in Simplifier, you will see that this profile has been created, and you can see how it's being rendered on Simplifier, and you can validate it there as well. So those are actually the step 7 and 8 to publish your work to your Simplifier project and to hit the validation options in Simplifier. So yeah, we've been through quite some steps that show you some basic concepts on how to create your own profiles to adapt FHIR to your use case. If you want to, well, during DevDays and also after, you can reach out to me if you have any questions about the exercises, and I'm glad to help you out. And lastly, this is just the first Let's Build session of the Let's Build a FHIR specification track. We're here, and after this session, you will be able to also attend or go to the FHIR shorthand tutorials, where you can use FHIR shorthand to create profiles and an implementation guide. And the tutorials and sessions on Wednesday and Thursday are more about creating implementation guides. So if you have your set of profiles, you can put them in neatly together and make an implementation guide. So we still got 2 minutes.
Yeah, hi Ardon. Thanks for the great session. During your session, we were also answering some questions on the Q&A tab on Hoover. But there's an interesting question here coming up from Julia. Can I create a new profile if there is no core profile that fits the need?
No, you need to create a profile with a base resource on top of it. You can't do anything. You can't really create a structure definition based on nothing.
Well, you can create it from resource, right?
Yeah, well.
Then you're creating a custom resource.
Yeah, but exactly. You're creating a custom resource, or you're creating a logical model. That's an option. Or you also have the basic resource, where it is very flexible and you can put it with extensions, but it's very ugly. Yeah, so in the general sense, you create a profile on top of a base resource from, for example, FHIR or another profile. And otherwise, you will need to go for it, indeed a custom resource, and try to get your custom resource being listed by HL7 and try to make it an actual resource.
Yep. Another question is, Ilya, how can I load a profile to a FHIR server to enable validation with it?
Well, that really depends on the FHIR server. But you need to, well, I think it can be through various ways, by either pushing it to the administration endpoint of that FHIR server, or importing it using the graphical interface. So it really depends on the FHIR server on how to get the structure definitions in the right place.
All right. And there was also another question, but I could not answer at the moment. What is mapping to RIM?
Oh, yeah, so by the base resources in FHIR already have a mapping to relevant other data models, for example, to HL7 version 2 or version 3, and also RIM. That's another data model. And the FHIR definition, or the FHIR spec, provides mappings. And you can also add your own mappings to a profile where you can say, okay, this specific element maps to my own functional or logical model. So one quick, if you go to, for example, the patient, here, every resource has a mapping tab, which shows the mappings that are inside the resource. So I think RIM should be here too. Yeah, the RIM mapping. So I think it has to do something with version 3.
That's very clear. All right. I think that were all the questions that we could ask here. The Q&A tab will be open, so we'll keep an eye on that. We can answer it after this session.
Yes, I will go through them. Okay, then we're done here. So enjoy your dev days, and please reach out if you have any questions.